Hi everyone, welcome back to the channel Your Techie Buddy. So this is the part 2 of the very important Java 8 interview question series, and in this part we are going to continue functional interfaces, right? So if you remember, in the previous part I have discussed about lambda expressions and how the relationship between lambda expression and functional interfaces are with the example. If you have not watched that video, please watch that video first so that it will be very clear to understand this already defined interfaces which we have in Java 8. So first question is, what are some of the important and commonly used functional interfaces type? So few important functional interfaces which were introduced in Java 8 or are very commonly used are function, predicate, consumer, and supplier. All these are very important topics for any interview for you to crack. And if you are attending a Java interview and if the interview is entering this Java 8 questions and you are clearly explaining the importance of this, you have very high chances of clearing the interview. So let's get started with function interface. Before that, I'll just quickly go back to the example where we have left in the previous part. So if you remember, so in the previous lesson, I showed you this is say hello method, right? The typical how we write a public static void say hello method. And this I have converted to a lambda expression, this one, right? And to use any lambda expression, you know we have to declare a variable, and that variable should have a type, and that type is nothing but a type of functional interfaces which I created last time and I showed you. So this is a functional interface which I created. Now we are going to see what are the functional interfaces which Java has already provided us. Before that, I'll just to reiterate, or for the people who are directly seeing this video, I'll explain once more quickly. So yeah, let me take a method here. Uh, Public static, suppose int square me. This will take an integer int a, and this will suppose return a into a, right? So this is a typical method how we write, right? Now we'll convert this into a lambda expression. For lambda expression, I told you, right? We have to give a parenthesis, then that should for mandatory have an arrow which should point to the body. This is how the lambda expression are, right? Now this parenthesis is nothing but this will take the argument. So argument here is, sorry, the argument here will go inside like this. And for the body, let's copy this. Okay. So this needs certain modification, like the argument here, as I told you last time, the argument need not have a type. For any lambda expression, what we'll do before this parenthesis, whatever we have, we will just remove all this access specifier, the name, the return type, everything. Only this. And in this also, the argument which you are taking, you'll just give the variable name, don't have to specify the type, right? And then if you have a single statement in the body, you can eliminate this curly braces, right? This is what I showed you last time. Now here, we don't even need the return. I mentioned you last time, right? So we'll remove the return. So this is our lambda expression. This whole method is converted to this single line of code. Now to use this lambda expression, you remember I told you we have to suppose apply it to a variable, save this expression to a variable. Let us square this, okay, the variable name. Now we have to give a type to this variable. This type will be nothing but a functional interface. So I'll give a name here, suppose square, right? So this functional interface should match the signature of this method, right? I'll declare a functional interface here, interface square. And this you remember, right? Functional interface are those interfaces which will have only one single abstract method, and it is not mandatory to use this at the rate functional interface, but it is a good practice to use this annotation. Now this abstract measures should match the signature of this, what we are expecting from the output, right? So it is public static int square me. So let this method be suppose square me, right? We are expecting a return of integer here. We are passing a int value, any name, int x, right? So this is the signature of the only single abstract method which this has, right? So now you see the compiler stopped complaining because we have given this lambda expression a type, and a type of this variable to which we have assigned this lambda expression is a functional interface, which is accepting the things which we are supposed to accept. Now this we need not have to use square me. Now how to use this lambda expression? To use this lambda expression, use the variable name dot, invoke the method of your interface, and then pass suppose 2. So this will return you the integer, right? Now if I do s out square of 2 is, okay, so square of 2 is 4. So this is where I stopped last time, right? Now if you see all these methods I've converted into lambda expressions, and I've used the functional interfaces to invoke them. So let's remove all these methods. We don't need this anymore. Okay. Okay. What is the next step? Suppose I have this square me. Suppose I want something like my lambda expression to take a string and return me a concatenated string. Okay. Suppose I want to tell my lambda expression to take a string s and just return me. Okay, I'll just write it here. It will be more clear, right? Next static void. Let it return a string. This will not be void. Let it take a string. Let it return a string. Say hello method. It will take a string str. Now return me hello plus str. Right? So this is a method which takes in string and returns me a string. Okay. So how to convert this now? Now this is the lambda expression. We'll just make an empty parenthesis, the arrow, and the body. Right? So what will go inside this? String str, right? The parameter will go inside this string str. What will go inside this? The body. We did not have the return. We'll just copy the body. So only a single statement, we can eliminate the curly braces, as I said, right? And for str, we need not have to specify the type, right? And one more thing, you can even go ahead and reduce this parenthesis if you have only one parameter here. So like I can reduce this parenthesis here, but then I find find it more precise to keep the parenthesis. It gives an impression of, okay, these are the input parameters. This is also optional if you have only single parameter. Okay, now this is what it is doing is it is taking one string and returning us a concatenated string of that, right? So it will take one string, it will return us a string, take one string, return us a string. So we don't have a functional interface matching this, right? But we have something similar here, which we had this square, right? It takes one input, but that is an integer, and it returns us an integer. Can we reuse this? Yes. What we can do is we can make, you would have heard about generics, right? So let's make this of generic type. What I'll do is I'll tell t comma r, where t is the type of the argument which we are passing in, which is like this, and r is the return type we are expecting from the method. Now if I do this, this become generic. Now this square we can use here directly, but here you have to tell what are you expecting. So the input I am giving is integer and the output I made it. So now this has this is a functional interface which we have created, but now it is a generic one. Okay. Similarly, now I can reuse this, right? Because it is a generic one, I can reuse this. Greet is equal greetings. Let this be the variable name. I can reuse this interface if you see, but here I can specify the expected type. That's it. The same interface I've just made it generic, and I'm able to use it for integer also, for string also. Now if you go here, you can just do an s out of, we'll call, invoke that method greetings dot square. Ignore the name for now. your techie buddy, right? Now see, I'm using the same functional interface. I made it generic. I'm using it for integer also. I'm using it for string also. Now let's run this. See, square of 2 is 4. Hello, your techie buddy, right? So last time we said this is what these are the functional interface which we have created. Now what is Java 8 has provided us many functional interfaces which are already present in the Java library. You need not have to create a functional interface every time. This I did it because to show you how tightly coupled are Lambda expressions and functional interface, and how comfortably you can build your own functional because in interviews they ask you, can you write your own functional interface? That's why to make this concept clear, I have first come up with this approach. Now what I can do, you'll see how easy it is, how easy our life is made in Java. We need not have to write. So now see what is the signature of this interface. Square t comma r, square me t, like this, right? Now there is a, what if I say there is a matching functional interface which does this in Java, and the name of that interface is function. Now this square, which is my functional interface, I'll change this to function. This is already there in Java. If you see, it got imported from Java util function, right? So now this is come function, and instead of square me, because now no more I'm not using square, this interface square me was for this, function comes with, if you dot apply. This also takes one integer. If I'll take you to the signature, if you see, it is a functional interface. It is an it takes t and r, and it has this apply method. This is same as it is a functional interface. It takes t and r, it returns it. That's it. Java has made our life easy by providing this function. Similar thing for string also we can do function, and here we can call apply. That's it. Now we can remove the functional interface, whatever we created. That is so simple. If you see, this is what function is all about. If I run this, see, same output, right? So this is a predefined functional interface which we have in Java, and the package in which it is java.util.function. If I expand this, I'll show you. See, it comes in function. There are so many functional interfaces you can explore. In this, I am going to explain about function, predicate, consumer, and supplier because these are the most commonly used one. Let me give you one more example, which I did in the part one, right? If you see addition, sum is equal to a comma b, a plus b. So what is this? Now we saw that function accepts one. If you see t, the type of the input it accepts, and r, only single output it will give. But this was example which I had addition. This is the functional interface. This takes two input but gives one output, but there are two inputs. So do we have anything like that for predefined already? Yes, we have. What we can do is function also takes the same, right? It takes one input, it gives one output. But same thing we can do when we want to give two inputs to the function. We can just use by function. So here you need to specify what are the two inputs, integer, comma integer, right? And what am I expecting? An integer. That's it. And by function is also comes with apply, and you pass these two. If you see, I'll just show you by function is also part of the function, Java util function. This is nothing but a function which accept two inputs. So two inputs and return one output. Now my this interface, whatever addition interface also I've replaced with by function, which is a predefined one in Java library. Now if I run this, that's it. I get the desired output 30, right? Now we'll go back to our slides. So what are some of the common use functional interface types in Java 8? Function, predicate, consumer, and supplier. Just now I explained about function. So function interface represents a function that accepts one argument and produces a result, right? So this accepts one argument. This function interface take one argument, which is the string, and returns as a result, which is a string. Similarly, it takes one argument and returns one. That is what function is all about. It takes t returns R, and the method which we use in the function interface is apply, right? For example, function string integer, function s dot length. You can get the length of the string here, right? This also returns as integer. Take strings, returns integer. This is all about function. Then by function, just now I explained you, it is nothing but it represents a function that accepts two arguments and produces a single result. It takes two arguments and produces single results. It took here integer, two argument a comma b and produced a result of type integer. This is what T, U and R. T and U are the type of the input, the type of the first parameter, the type of the second argument, and then the type of the result is returning. So for example, add a comma b, a plus b returns the add. I hope function and by function are completely clear. If not, let me know. This is a very small question series which I'm doing only for from interview point of view. If you want complete explanation on all these things, I can create a complete tutorial also. Now let's go to predicate. So what is predicate? Predicate is a functional interface that represents an operation that takes a single input and returns a boolean value. So predicate always returns a boolean value. That's why it has, if you see the signature only has T. T means the input type, whatever. You have to only specify the input type because the signature already has boolean. It has a test method. The only abstract method in predicate is the test method. So the return type is already boolean. You only have to specify T. Let me give you an example of predicate also. So uh, first let me create a method. We'll get rid of this method. We have already converted it. Public static void, no, let it be boolean check length. We'll give the input here as string str. What we'll check here is if str.length is greater than 5, return true, else return false. Okay, so this is my method. It is returning me a boolean value. What is the, it takes an input of string and it checks if whether the length of the string is greater than 5. It is greater than 5, then true. If not, returns false. So let's convert it to lambda expression, open parenthesis, arrow and curly braces. Take the parameter, the argument str. What should be the body? This is the whole body, right? So this will convert it, we'll write it here. You just have to pass the condition here. That's it. Because test will always return a boolean value. You need not have to worry about the conditions, right? So we are expecting a boolean value. So what we have for, so this is the lambda expression we have. For each lambda expression, we should have a variable. So we'll give the name as check length, right? So this variable should have a type of functional interface. Now we know what is the functional interface matching our requirement, which returns boolean value and takes a single input. We know the functional interface, it is predicate. And for predicate, we just have to specify the type of input we are giving. So the type of input we are giving string, because by default, if you see, this is the predicate method. By default, the method here, the test method is the method which you are going to use. It has the return type is boolean. So you did not have to specify the R, whatever we were specifying here. In case of function, we'll only give the type of input. Now what we can do, we can use checkname dot test and we can pass your techie buddy. Let me just S out this. That's it, guys. So we have used a predicate. We are passing a condition here, this condition, and we are giving only one input. That's why we are using predicate, because we are expecting a boolean response. Just run this. See, true, right? Because your techie buddy is greater than 5, right? Now I'll just make this as, sorry, less than 5. Let's see what is the result. Now it is false. So it is that simple. See, we have converted this whole method into a very small Lambda expression, and the interface which we are going to use is a predefined one in the Java library, which is the predicate. Similarly, how we had by function, right? We have by predicate also. By now you know what by means, right? Two inputs. So now if I have, suppose, uh, I'll take, I'll create a Lambda expression. Okay. What I'll do, I'll take two inputs, a comma b. Maybe let those be integer. What I am expecting, a is equal to b. Okay. This is the condition I want to check. Check equality. Okay. And I will use here by predicate, and I'll give here integer comma integer. Return type I need not give because we are expecting a boolean, because we know predicate and by predicate will give us boolean. Now we'll s out this and we'll call check equality dot same test method, but the arguments will be two arguments here, 2 comma 3. Right. Now when I run this, we'll see what is the output. See, last output is false because 2 is not equal to 3. Now if I make this 3 and we'll run this, true, because both are equal. I hope this is clear. This is predicate, this is by predicate. Because predicate takes only one input, no need to specify the return type, it is always boolean. The method used to invoke for predicate is test, and the it already has boolean in the signature. Similarly for by predicate, we will invoke test with two arguments because by means two, and then when you go to by predicate, here you can see t and u both are the input parameters. So here you see the predicate interface represents an operation that takes a single input and returns a boolean value, right? I showed you, right? It takes single input and returns a boolean value. For example, check length. Similarly, by predicate, it takes two inputs and returns a boolean value. So two inputs are there. So we have covered function, by function, predicate, by predicate. It is very important. So now let's move on to consumer. So what is a consumer interface? So the name itself suggests, right? It consumes. A consumer is a functional interface which represents an operation that accepts a single input argument and returns no result. So the name suggests, right? You just pass the input argument, but you don't expect a result. If you see the signature, the consumer interface takes only T. You have to specify the type of the input you are going to provide, and it doesn't return anything. Though the signature itself has void, that's why you need not have to specify the return type. Now let's check the example for consumer. So we have done function, by function, predicate and by predicate. Now let's start with consumer interface. Okay. For consumer, let me start with a simple one, like say hello. This will take only one input, give only one output. So what we will give is suppose a string str. We are only going to write one statement, so we'll do s out, say hello plus the input string which we are passing, right? So we have to give a type to this. So we'll give the type as, because we are taking only one input and we are not expecting any output, we are just printing it. The body itself is printing it. That's why, and the integer type we are giving is string. So you can see this is the Lambda expression which accepts only one input. It only prints. It doesn't return anything. So so what for matching this, we have the interface called consumer. I'll show you the more here. If you see, it just take T, the input consumer, right? And now to invoke to use this, we'll use the say hello dot accept, and you can pass whatever you want, your techie buddy. Hello there. Now if I run this, See, it consumes your techie buddy and it prints, it gives us the output, right? Similar to by function, by predicate, we have by consumer also. So suppose I'll take two inputs now, a comma b, let it be two integer, and what we are expecting, we are expecting suppose sum of the two numbers are, we are expecting it to print two numbers. We'll add these two numbers a plus b. So it's a by consumer. We'll write by consumer. Give the type as integer because both are integer. And suppose I'll call this as add this. So this is the expression which take two inputs. It sums the two integers and it gives the output. So the variable is add this and the interface we are using is by consumer because two inputs, right? Now to invoke this, we'll write add this dot accept. Let the two integer be 2 comma 10. Now see if we get the output. Yes, the sum of the two numbers are 12. So this is all about consumer and by consumer. So consumer is a functional interface which represents an operation that accepts a single input argument and returns no result, right? Takes single input output, returns nothing. That's why the return type is void and we need not specify that in the signature. Moving on to by consumer. By consumer represents an operation that accepts two input arguments and returns no result. So it takes two input argument, integer and integer, and returns nothing, right? We can it will just consume and it will return nothing. Now let's move on to the last one, but important also, supplier, right? So as the name suggests, right? Supplier is something like consumer is something which consumes. Similarly, supplier is something which supplies us, right? It does not take any input, it supplies us. To just give an example for this, I would do suppose generate random. I'll just generate a random number. So it will take nothing. That's why we have empty parenthesis, right? Because this lambda expression will take nothing. It will just supply us what? A random number. Okay. So this is the lambda expression for supplier because it takes nothing but it will return us a value. But we'll just give the type here supplier, and what is the type we are expecting? We are expecting a random number, so it is double. So if you see supplier, we are expecting only the return type. If you see the signature of this, we are just getting it. It is accepting nothing. It will just give us the result, the type. So we have to specify the return type, which is double. Now if I do sout gen to call the method, we have get. Now if I do this, yes, it gives me it's a random number, right? So this is all about supplier. It takes nothing but gives us the output. I'll just move on to the slide. So the supplier is a functional interface that represents an operation that takes no argument and returns a result. If you see, the signature says T, which is the type of the result we are expecting, the type of the result supplied by the supplier. For example, you can have a supplier for local date of the type expecting a local date time. It will take nothing, but it will invoke this local date time dot now and give you the local date time. Right? Similarly, I have given you example for random number generation. It takes nothing but gives us a random number. So this was all about function, by function, predicate, by predicate, consumer, by consumer, and supplier. So these are very important interview question topics. I hope it is clear for you. If any doubt is there, please come let me know in the comment section, or also let me know if time permits. I'll create a tutorial also on this Java 8 topics because these are very important. Yeah, thank you everyone. Please like and subscribe to the channel so that you can get such contents. Very happy to help you. Thank you so much.